this in the first half of the videos, or the test hints. But let's just throw up those equations again. C equals F lambda and E equals HF. Louis merged those together, realizing that frequency was a component of each equation. So the top one, the speed of light, is frequency times wavelength. And the second one, energy, is Planck's constant times frequency. He's the one that blended that all together into E equals HC over lambda, that you guys were trying to use in your quantum ladder worksheet. Okay? What de Broglie did not adequately explain, or perhaps he didn't even try, was the photoelectric effect. Okay? So he knew that waves and particles were related, and he was relating them, but he did not explain for us the photoelectric effect. Number 18, how de Broglie used E equals HF, what it shows about the atom. So this, the equation tells it all. Energy is directly proportional to frequency. Okay? That's what he found out. Energy is directly related to the frequency of the radiation. Number 19, the part of the atom where the electrons are found. Well, we know they cannot be found where? They can't be found between levels or in the nucleus. So the electrons have to be in the electron cloud in those energy levels, and now we even know with the quantum model of the atom that those are in orbitals. That's going to be our last testing. Number 20, what determines the size and shape of the atom? That's the electron cloud. So the more energy levels there are in the atom, the bigger that atom is going to be. Okay? Of course, that would be, you need a bigger atom if there are more electrons in that particular element. With hydrogen, not so much, it's just got the one electron. 21, how the quantum model describes the location of electrons in an atom. We can't tell exactly where those electrons are, but we do know where they tend to be. Okay? So it's impossible to say that, okay, electron A is going to be right there in the atom, but we do know that it tends to be in an area called an orbital. 22, the major concept or idea behind each of the atomic models. This is another one of those, all of the following statements are correct except. Okay? So Bohr said, we've got this hydrogen atom, it's got one proton in its nucleus, it's got one electron in its electron cloud, and that electron is in a specific orbit, a specific energy level. And there were limitations to Bohr's model. We now know more. The quantum model says we're going to have, that electron is going to be in a probable region around the nucleus. Okay? Again, those probable regions are called orbitals. The first half of this chapter kind of hints at that, and then the second half of the chapter we're going to look more specifically at those orbitals. Okay? Rutherford's model had told us that there is a nucleus and the electrons were spread out around it, but the quantum model is our most recent explanation of what the innards of the atom are like. 23, the concepts involved with the Heisenberg uncertainty principle. Another one of those, all of the following except. Okay. Heisenberg uncertainty principle, you should know. In fact, I jot this on my cheat sheet for the midterm exam. It's impossible to determine the position and momentum of an electron simultaneously. We can use energy to measure or to try to find the electrons in an atom. If we hit them with some energy and find, we could say, okay, for that split second the electron was there, but then we've knocked it off on its course and it's going somewhere else. Or we can kind of follow it along and it's constantly changing its momentum. So we can't know both of those at the same time. And that should kind of make sense. Yep.
What was the location?
location and momentum, or position and momentum at the same time. 24, how the Heisenberg uncertainty principle and the Schrodinger wave equation blend to form the current model of the atom. Well, if the electron is behaving as a wave, then Schrodinger's equation is awesome because it allows us to approximate the location and basically says the electron's here, and now it's here, and now it's here, and now it's here, and so on. But it recognizes that the electron's position is constantly changing because it is moving so quickly. So, putting all those ideas together, de Broglie, Bohr, Heisenberg, Schrodinger, helps us pinpoint where electrons might be or where electrons tend to be, even though we can't say for sure exactly where they are. And number 25, how to define an orbital. Okay? An orbital is a probable region within the electron cloud where the electron will tend to be. And my analogy the other day in notes was, you know, think about if we could, in the middle of a school day, lift the roof off of the building and look down from above, and all the people in the school would be our example of our model of electrons, and they could move around anywhere in the building, but they tend to be in classrooms. People would tend to be in classrooms during a school day. Well, electrons tend to be in these orbitals. They're not actual physical structures. It's just probable areas within you. Okay, and that should do it for the first half of the chapter. Yeah.
For Heisenberg, is it physically impossible to know where it is?
Simultaneously.
But
We can't know them both at the same time.
Is it just technology, or is it?
Oh, could well be.
Okay.
Could well be, yeah. Okay.